Lesson 3.5 is quadratic inequalities. A quadratic inequality is an inequality of the form ax squared plus bx plus c is greater than, less than, greater than or equal to, less than or equal to 0, where a is not equal to 0. Notice that it's 0 on one side, just like when we solve quadratic equations, it always has to be equal to 0. A number line value is any value that makes a function 0 or undefined. For quadratic functions, there's nothing that makes it undefined, so we're going to be focusing on what makes that quadratic function equal 0. So when we solve quadratic inequalities, the first thing we always want to make sure is that one side is equal to 0. So if I want to solve 2x squared is less than x plus 10, I want to make one side equal to 0. So I subtracted the x and the 10 across, and now I have 2x squared minus x minus 10 is less than 0. So now I want to find where this thing is equal to 0. So I'm going to do that by checking to see if it factors first. So this thing factored into 2x minus 5 times x plus 2 is less than 0. And so now I want to find where it actually equals 0. So I'm going to solve both of these using the zero product property so that I get x is equal to 5 halves and x is equal to negative 2. And it's not less than, I'm just finding where it actually equals 0. So those are my two zeros, and that is where I'm going to put on my number line. So unlike other inequalities where we solve them first and then put the answer on a number line, for quadratic and higher order polynomial inequalities, we're going to use the number line to help us solve the inequality. So I put my two zero values on my number line, negative 2 and 5 halves. Because this is a strictly less than, I know both of these are going to be open circles because I don't want to include where they actually equal 0. So now, in order to find where it is less than 0, I have to test points in each of these intervals. So I'm going to test an x value that's less than negative 2 and see if it makes the function positive or negative. I don't actually care what the value of the function is, I just care whether it's positive or negative, and you can pick any value that's less than negative 2. So I picked negative 10, so if I plug in negative 10 to the factored form here, I get 2 times negative 10 minus 5, which is going to be a negative number, and I get negative 10 plus 2, which is also going to be a negative number. So I have a negative times a negative, which means I end up with a positive number for all y values for x is less than negative 2. So now I'm going to pick a number that's between negative 2 and 5 halves and test that and see if I get a positive number or a negative number. So I tested x equals 0 because that's a nice easy number between negative 2 and positive 5 halves. So 2 times 0 minus 5 is going to be negative, and 0 plus 2 is going to be positive. So I have a negative number times a positive number, which means the entire thing is going to be negative. So all of my x coordinates between x equals negative 2 and x equals 5 halves, if I were to plug them into the function, they're going to give me negative y coordinates. So that section in there is always going to be negative. So now I'm going to do the same thing for a number that's bigger than 5 halves. So I picked x equals 10. Again, any number that's bigger than 5 halves works. And so I plugged it into my factored form. 2 times 10 minus 5 is going to be a positive number. 10 plus 2 is going to be a positive number. So a positive times a positive is going to be a positive. So any x value greater than 5 halves is going to have a positive y coordinate. So then, if I want where this thing is less than 0, I want to think about what types of numbers are less than 0, and those are negative numbers. So I want the section of my number line that ended up negative. So that was in between negative 2 and 5 halves. So then my solution to this inequality in interval notation is negative 2 not included, up to 5 halves also not included. So when you solve these inequalities, one side equals 0, factor it. Anything that makes it equal to 0 goes on your number line, and then you test values in each of the intervals to see if they're positive or negative. And then looking at your inequality, do I want positive or negative numbers? And then you chose that section. So for this next one, we have x squared plus 8x is greater than or equal to 0. So one side's already equal to 0. So go ahead and pause the video and solve this quadratic inequality. So since one side's already equal to 0, the first thing I did was factor it. So I factored an x out of x squared plus 8x. I got x times x plus 8. Then I found where this thing equaled 0. So it was x equals 0 and x equals negative 8. And I put those two values on my number line. Then in every single interval, I tested a value in that interval, and it doesn't matter what one as long as it's in that interval. And I tested to see whether the function was going to be positive or negative. So for x is less than negative 8, I chose negative 10, and you end up with a negative number times a negative number, which ends up being a positive number. Between -8 and 0, I chose -2, so you end up with a negative number times a positive number, which is a negative number. And then for x is greater than 0, I chose x equals 10, and you end up with a positive times a positive, which is a positive number. So then looking at my inequality, I noticed that it's greater than or equal to 0, so I want the sections where it's positive because those types of numbers are greater than 0. So I chose everything from -infinity to -8 included because it's or equal to, or 0 included all the way to infinity. So go ahead and pause the video and try the last one. 2x squared plus 16 is less than 40x. So the first thing that I did was I made sure one side was equal to 0, so I subtracted the 40x across and got 25x squared minus 40x plus 16 is less than 0. Then I noticed that this was a perfect square binomial, so it factored into 5x minus 4 quantity squared is less than 0. So then I needed to find where this thing equaled 0, and it would equal 0 at 4/5, so I plotted that on my number line, and it's an open circle because it's not or equal to. So this one only had 2 intervals, so I tested on either side. For the first one, I plugged in 0, and I got a negative number, quantity squared, so it ends up being positive. And then on the right side, I picked 10, and I got a positive number, quantity squared, so again, it was positive. Then I looked at my inequality, and I noticed that I went where this is less than 0, but both sides of this is positive, and this one is not included, so there's no possible number that would make this inequality true, so it would be no solution. If this was a closed circle, then the only one would be just x equals 4/5. If these were negatives, then you would have a lot of options. So this one was a little bit funky. Suppose that a manufacturer of a gas clothes dryer has found that when the unit price is $P, the revenue R in dollars is R of P equals -4P squared plus 4,000P. So given that, we want to find the price that maximizes the revenue, the maximum revenue, what prices P for the revenue is 0, and a reasonable domain for this function. So A through D are all review of previous sections, specifically last section. And then we can talk about E for what range of prices will the revenue exceed 750,000. But go ahead and pause the video and do A through D. So for the first one, I used -b over 2a, where b is -4,000, or b is 4,000, so -4,000, and a is -4, so you get -4,000 over 2 times -4, or $500. So that's the price P that would maximize revenue. And then I plugged that into R of P and got that the maximum revenue would be $1 million. So then for part C, I set our revenue function equal to 0 and factored, so I took out a -4P and then times P minus 1,000, and I set each equal to 0, and I got P to be 0 and P to be 1,000. So then for the reasonable domain, I would want everything in between that because I don't want to have a negative price or a negative revenue. So 0 is less than or equal to P is less than or equal to 1,000. So for the last one, I want to know what ranges of prices will the revenue exceed 750,000. So I'm going to set up an inequality. So I have -4P squared plus 4,000P is greater than 750,000, and I'm going to solve this like the previous ones that we were talking about. So I moved the 750,000 over to the other side so that one side's equal to 0, and then I factored. So first I factored out -4 just to make everything a little bit easier, and you get P squared minus 1,000P plus 187,500. And then I factored this into -4P minus 250 times P minus 750 is greater than 0. So now I can find what makes my thing equal to 0. So I get P is equal to 250 or 750, and I'm going to put those on my number line. I'm also going to include 0 and 1,000 because I know that's my maximum and my minimum that I want to have. And then since this is strictly greater than, I'm going to put open circles. So now I'm going to test values in each of those intervals. So between 0 and 250, I plugged in 1, and I got, including this -4 in front, I got a negative, a negative, and a negative. So 3 negatives makes the whole thing negative. Between 250 and 750, I plugged in 500. So again, the -4 is still negative. The first term would be positive, and then the third one would be negative. So I end up with 2 negatives, which makes the whole thing positive. And then for between 750 and 1,000, I plugged in 800. And again, the -4 is still negative. And then the 2 other terms are both going to be positive. So 1 negative makes the entire thing negative. And then I want where this thing is greater than 0. So I want where it's positive, which is going to be the section in the middle between 750 and 250. So my answer is going to be between $250 and $750. So this has been quadratic inequalities. So whenever we solve a quadratic inequality, make sure that you factor it completely, find where it equals 0, and then put those numbers on a number line, test each interval, whether the function is going to be positive or negative, and then decide based on your inequality whether you want the positive or negative sections.